Now that you know a bit about what React is and what purpose it serves, let's also know a bit about the environment in which React works. As I had mentioned earlier, React is a JavaScript library, and one of the key features of React is that it helps to leverage the latest features of JavaScript by following ECMA script specification. ECMA script is a scripting language specification that lays down general rules and guidance which a scripting language like JavaScript must conform to. There are various editions of ECMA script, and one such edition was released in 2015 with the name ES6. This edition was later renamed to ES 2015. ES6 significantly added new syntax in JavaScript. You have already learned this syntax in the previous module, which was based on advanced JavaScript concepts. React recommends that you use ES6 so that your code can use latest features and follow a syntax that can help you in building complex applications easily. But is that all about it? No. All the browsers do not support ES6 completely. Almost all the browsers still run ES5 code, but does that mean that you cannot use ES6? No. As you can recall from your last module, we have something called as Babel. Babel is a JavaScript compiler that does the job of converting ES6 code into ES5 code. So you can code in ES6, give your code to Babel, and leave worrying about browser support. Thus, this helps you leverage all the latest features while letting Babel take care of the browser support. You can refer to the previous module of Advanced JavaScript, where you have learned the syntax of ES6 and new features in JavaScript. You can also find some useful links in the additional resources to read more about ECMA script specification, ES6 edition, and Babel. As web applications grow increasingly complex, making them scalable becomes of utmost importance. In the past, people used to write ad hoc JavaScript, but nowadays, building a web application requires more discipline and formal software development practices. When an application grows on a large scale, there are many requests being simultaneously made to the server. In case you have hundreds of JavaScript and CSS files, your application's performance degrades because it has to reference these hundreds of files. This becomes worse with the fact that most browsers allow only a limited number of connections to each host at a time. Usually this number is around 6. This means that all the assets are not loaded in parallel. Now, if you have one web page that is referencing 10 style sheets and 20 script files, then you need to request 1 plus 10 plus 20, which is equal to 31 individual files. If we consider the batch size to be 6, this would require 6 requests to be made. So what do you do in such a case? This is where bundling helps. Bundling reduces the number of HTTP requests by merging multiple style sheets or script files into a single file that can be loaded at once. Thus, if you go with bundling in the above scenario, you need to reference only 3 files: one web page, one bundled style sheet containing all 10 style sheets, and one bundled script file containing all 20 script files. Thus, referencing these 3 files can be achieved in a single HTTP request as opposed to the need for making 6 requests in the earlier case. The next step that you can take is minify your files. What minifying does is strips your code of all such data which is not required for executing the file. In short, minification shortens a file's contents without changing its meaning. This reduces the overall file size, thus resulting in faster response times and lower bandwidth costs. Now comes the bigger question: how do you bundle these files? There is something called as Webpack. It's a module bundler used for modern JavaScript applications. It can be used to bundle images, styles, and scripts into your application. As you can see in this image, there are different modules with dependencies such as JavaScript files, CSS files, image files, etc. Webpack bundles these modules with all the dependencies into static assets with one file containing all the individual files of a type. Now, how Webpack does this internally? While processing your application, Webpack internally builds a dependency graph. This dependency graph keeps track of every module that your application needs and its corresponding bundle generated by Webpack. There are other module bundlers too, such as Browsify, but Webpack has quickly become the first choice for many React developers. Webpack also packs other magic under the hood, which makes it a great tool for building large full-stack applications.